Hey everybody, welcome back. It's another school year, another exciting time. Times are very different these days. But before I get into our 1.1 notes, I want to talk you through a few things about, where we're going to see our notes, where our homeworks come from, like how to access all of that stuff, in case you weren't sure. So first thing I want to point out is you guys are all familiar with My Learning. So My Learning, also known as Canvas, if you ever hear people say My Learning or Canvas, they're talking about the same thing. So you guys know that's where you'll log in for Zooms. You'll see that in the announcements. You'll every day when you want to get into class, you'll hop in there to click on my Zoom link. It's also going to be where we take our quizzes. When we take quizzes, we'll do them in My Learning as well. Also, My Learning, the class that I have in My Learning links everything to our textbook, which is SAVAS. Our textbook is SAVAS. That's what it's called this year, and it's all online. The notes and everything are there. Now, I recommend, obviously, as we go through the notes, we write them down on paper, physical paper, so that we have a collection of it and we can keep it all in the same place, and it helps us remember things better. But also, our homework is on there as well. So how you'll access SAVAS, though, is actually through another app icon on your dashboard. So on your dashboard, when you log into My Passcode Connect, you'll see SAVAS Easy Bridge. So when you click on that, it will take you to this page. I believe it'll be this page. It might be a little different for you guys. I'm not sure. Where it'll show you your classes that use SAVAS. It might be just mine, or you might have one or two other ones in there as well. But when you click on the little drop down, it says Envision Florida Algebra 1. This is the textbook. So when we click on that, it'll open our textbook, which brings you to the SAVAS website. So here is the online textbook and all the assignments that you will do. When you log in, you'll see assignments here where if I've made an assignment for you to do any homework, that's where you'll go to get the homework problems done. So I've already made one assignment for you guys. So when you log in now, you'll see that assignment and you can start working on it. Here is the textbook. So this is where I'm going to go to start our notes. So some of this might look different for you because obviously you're a student, I'm a teacher. But for me, right here, topic 1 is where we're going to begin. And all the stuff that you see right here, every one of these is in your My Learning page. So you can go to My Learning and you can access all the stuff that I'm going to do through My Learning. But it's also, like I said, it's just on the dashboard here, the SAVAS website itself. So I like to use that because it's a little easier. But yeah, just to show you quickly, I hope it doesn't break on me again. When you go to modules, everything here in the modules, so you'll see topic 1, this module, you'll see all of this stuff right here. I'm not going to click on it because sometimes it breaks when I try to have this open at the same time as the actual textbook. But all this stuff right here, the virtual nerd, step 1, step 2, all of this stuff is directly on this website, which I'm going to show you now. So I like to use the website just because it doesn't give me issues. Sometimes, like I said, it gives me little issues going through here. So, but either way, let's go ahead and let's begin, right? Lesson 1.1, operations on real numbers. So yours, I don't know what you guys will see on your screen, but for me, I've got the teacher's edition right here. When I click on that, it just opens the textbook up. And the actual textbook is the exact same thing, like word for word pretty much, as all the stuff that's in here. So these are basically like different pages or different cutouts from the textbook itself. It's not any additional stuff. It's literally all the same thing that's in the textbook. So if you guys have you should have, if you're working at home or working in school, if you're working at home, you should have come to school to pick up a workbook. It's like an inch thick or so. It's kind of a disposable textbook, if you will. If you haven't gotten one of those, you need to come to school and get one. I believe they hand out to all the students who are learning online. That book has it's basically the same as the textbook. It has all these notes in it or these examples in it, and it has all the homework problems as well. But we're going to do all our homework online. so that it's easy to grade. You get multiple chances at answering the questions, right? You get more opportunities by doing it online than doing it in the book itself. Plus, we can't really collect paper because if we collect paper, that spreads germs, and we're trying to avoid that. So to limit that, we're doing all our stuff online. So step 1 and step 2 here, step 1, explore, step 2, understand, apply. These are essentially the notes that we're going to take in class. We won't go through all these pages, but we'll go through most of them. And step 3 is where your homework will be. So I'll pick problems out of there and I'll assign them. So it's all the same problems you'll see in the paper disposable textbook you have. They're all pretty much the same problems. Sometimes they're a little different, but not really. But I'll assign them digitally on here, and you guys can try and do those problems online for all the reasons I've already said. So I'll assign problems from step 3, and that's where you'll see when you log in to the textbook, you'll see assignments. That's where I'm getting the assignment from. I'm taking problems out of here and making them assignments, and you guys will already see the assignments when you log in. So you don't have to go to this part of the screen. You just, as soon as you log in, I believe it's in red right in the middle. It says 1 assignment due or 2 assignments due, whatever, right? But just know this is where I make them from. They're step 3 in our textbook. So just kind of an introduction. Now I'm going to skip step 1. I'm just going to go straight into step 2, which is understand, apply. So we can start our notes for section 1.1. All right. So now let's talk about our first example. So in the set of numbers from 1 to 10, which elements are in both the subset of even numbers and the subset of multiples of 5? Now, before we answer that, let me talk a little bit about what a set of numbers is. So let me go ahead and get snip this right on it. So before we even answer this question, let's talk about a set, okay? So sets are usually denoted with these little brackets. And sets can be anything. They don't even have to be numbers. For example, if I said my class is a set, then all the elements or pieces of that set would be like the students. So for example, I'll call this set class, and the set will contain every student in my class. So I haven't learned you guys' name yet, so I'll just make them up. Billy, Jeff, okay, Ed, Wardo, whatever. Jess, right? So let's just say I have 4 students in my class, just to make it easy for now, right? That's a set. A set is a collection or a list of things. Obviously, in math, we're going to have sets of numbers most of the time. So if I call set A, just to name it something, it could be a set with numbers. It can be just 1, 2, 3, 4, 5, 6, right? Or I can make a set that's even numbers, right? I can give it a different name. I can call it B, and I can put even numbers, right? 2, 4, 6, 8, 10, 12, right? And if I draw a dot, 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 that means the set would continue all the even numbers forever, basically. If I don't put the dot, 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 then I'm only saying essentially here in this case, I'm just saying all the even numbers up to 12. So, but that's what a set is. It's just a collection of stuff, okay? So a subset, real quick, let's go back to the class one real fast. A subset is a smaller set within a set. So if this is my whole class, right, and I break it into groups, right? So let's say I put Billy and Jeff in a group. Billy, Jeff. Now this set is now a subset of the class. Subset is basically a smaller set coming from a bigger set. So everything that's in here has to be contained here. So let's say I put Billy and Jeff in a group, that's a subset. But if some outsider from a different class period comes in, like let's say Frank, forget that guy, right? This isn't really a subset anymore because all of these names don't come from my class. So I can't really call this a subset because it's, Frank doesn't actually exist in my class. He's not a part of the original set. So this would just be a different set, essentially. But so what I'm trying to say is a subset is going to be any of these, but only those, only like it could be a smaller collection of it. Like I said, grouping you guys into groups. That creates a subset of a larger set. So just some information to talk about. So that's generally just a quick rundown on sets. So now let's go back and let's try to answer this question. I'll leave those alone. So in the set of numbers from 1 to 10, so that set is referring to numbers from 1 to 10. So it's saying 1, let's write it all out, right? 1, 2, 3. This is where you can take notes. You guys can write this stuff out on paper and try to keep it all together. So here's your set: 5, 6, 7, 8, 9, 10. There's a set of numbers from 1 to 10. So basically I just made this, right? I wrote this all down. Which elements? So elements are the pieces of a set. So like 1 is an element of the set. 2 is an element of the set, right? It's like members, right? It's a single number in the set. So like Billy was an element of the class set, right? It's one of the members. So these are all just elements. So 3 is an element, 4 is an element, 5 is an element, right? So that's what it means by elements. So something, just as a number within the set. So which elements are in both the subset of even numbers and the subset of multiples of 5? So a subset of even numbers. So using this as our base set, right? This is like the class. This is the full set. A subset of that, which we'll put the subsets in blue. So we want a subset of even numbers. So the even numbers within this set would be 2, 4, 6, 8, and 10. So we're going to write that out: 2, 4, 6, 8, and 10. So this is our subset of even numbers. But also we need a subset of multiples of 5. So I'll just call it mult 5, right? That'll be the name of the set. So multiples of 5. Multiples of 5 are things that 5 multiplies to make. So for example, 5 times 1 equals 5. So 5 is a multiple of 5. 5 times 2 equals 10. So 10 is a multiple of 5. So basically numbers that are divisible by 5 are multiples of 5. So 5 times 3 would be 15. So 15 would be a multiple of 5. But 15 is not in the set, right? So the only numbers that are multiples of 5 in the set would be 5 itself and 10, because 5 times 1 makes this one, and 5 times 2 makes this one. So that set would just be the numbers 5 and 10. Now, to answer the question, it says which elements are in both of those subsets. So what number is in both of those sets? The only number that both sets here have in common would be the number 10, right? 10 is the only number in both sets. So to answer our question, the answer here would be 10 as our final answer. So when we click on it, solution, it shows you all the same stuff that we just said. And of course, it says the number 10 is the only number that is the element of both sets. So let's try another one, right? So let me snip this. And here we go. So which numbers are in set A, or which numbers in set A are elements in both the subset of odd numbers and the subset of multiples of 3? Now, A is already written out for us. They have our set right here. So this is like the class. This is the overall set. Let's go ahead and write the subset out. So we have the subset of odd numbers. So the odd numbers from here are 1, 3, 5, 7, and 9. So 1, 3, 5, 7, and 9. So these are our odd number set. And we also need another subset that's multiples of 3. So multiples of 3 would be 3 times numbers to get a result. So 3 times 1 equals 3. That's a multiple. 3 times 2 equals 6. So that's a multiple. 3 times 3 equals 9. So that's a multiple. 3 times 4 equals 12. This is a multiple, but you can tell 12 isn't in the set, right? So numbers that are multiples of 3 are the same as numbers that are divisible by 3, And in that case, that would be the number 3 itself, number 6, and number 9. 3, 6, 9. Those are all multiples of 3. So let's write that. So multiple of 3. That's going to be 3, 6, 9. So the question again is, which elements are in both of those subsets? So what numbers are in both of these sets? Well, 3 is in both of them, and 9 is in both of them. So our answer is 3 and 9. Because those are the only numbers that are in both of those subsets. Right, simple enough. So I'm just going to type in 3 and 9. It might just want 3, 9, whatever, but it tells you the correct answer. 3 and 9 are in both the subset. It doesn't really grade it. It just kind of tells you the correct answer here, which is cool. It's nice for us to be able to check to know if our answer was right. All right, so now let's exit this because I'm out of examples for that. So we'll move on to the additional example, right? So we just did this one right here. We're going to do 1 additional example 1. Because more practice is better. All right, in the given set of numbers, which elements are in both the subset of numbers divisible by 2 and numbers divisible by 3? So let's get ready to write on this. So here's our set. Now notice it's not 1 through 10 like it was before. Right here it's 5 through 12. So let's make the subset of numbers divisible by 2. So divisible by 2. That means the same as a multiple of 2. So of all these numbers, which ones can I divide by 2? 6 can divide by 2. 8 can divide by 2. 10 and 12. So 6, 8, 10, 6, 8, 10, and 12. These are divisible by 2. Now I also need a subset that's numbers divisible by 3. So divisible by 3. So 5 is not divisible by 3. 6 is. 6 can be divided by 3, right? 6 divided by 3 would equal 2. 7 wouldn't work. 8 can't divide by 3. 9 divided by 3 would work. So 9 counts. 10 doesn't divide by 3. 11 can't divide by 3. But 12 can. 12 can divide by 3. Because 12 divided by 3 would be 4. All right, so I've made my subsets. Now I'm answering the question, which elements are in both? So let's see, 6 is in both of them. 8, 10, 12 is in both of them. And that's it, it looks like, right? Just 6 and 12 is our answer. The solution, they got the subsets like I wrote them. And it says, yeah, 6 and 12 are our answers. So we'll go back to exit because that was the only additional example. And we'll move on to compare and order real numbers. All right, now I'm going to pull up my calculator for this, so give it a second to load up. If you have a calculator at home, that'll be helpful. I thought there was a calculator on this website somewhere we can use. I'm not sure. If you guys find it, you can let me know. But I'm going to pull up the one I have on my computer. You really need a calculator for these questions. There's no way I think you can really. Oh man, I didn't mean to click on that. I don't see there being a way you can really answer these questions without a calculator. Just to be straight up with you. All right. So it wants us to put these numbers in numerical order. It wants these in order from least to greatest. So we have to figure out of these numbers here, which one's the smallest and which one's the biggest, right? And we'll list them all in order. So I have 40 elevenths, the square root of 324 divided by 36, and the square root of 10. So which is the smallest, which is the biggest? How am I going to tell? Well, with the calculator, it's actually very, very easy. So 40 divided by 11 is our first one. So all we have to do really is just 40. 40 elevenths as a fraction is just the same as 40 divided by 11. So keep in mind a fraction is the same as division, right? So 40 over 11 is 40 divided by 11. So a decimal is very easy to help us figure this out. So 3.636. Let's write that. So 40 elevenths is equal to 3.63. So decimals are easy because we can obviously tell, which is bigger and smaller if they're all in decimals. So that's what I'm doing right now. I'm trying to put all of these numbers in decimals. So next, I'm going to do our 324 over 36, but it's a square root. So my square root button, I'll hit second, and then here you see a little square root. And now I have to type in 324 divided by 36. And notice that all of that is still under the square root. So if you have a different calculator than me, you might have to type it in like this. You might have to, once you hit the square root, hit parentheses right after you hit the square root. So let's start from the beginning. So hit your square root button, and then hit parentheses, and then type in 324 divided by 36, and then close the parentheses. So that way we're sure it'll work. So hit enter, and that number is 3. Okay, so that's very nice. So the square root of 324 divided by 36 equals 3. Now I just have to do the square root of 10. So do the same thing. I'll hit the second, and then this button gives me square root. Square root of 10 equals 3.16. So square root of 10 is equal to 3.16. So now I have my numbers, and now I know which one's in order from least to greatest. So the smallest one is the 3. So that means the square root of 324 divided by 36 is the smallest number. So square root of 324 divided by 36 is the smallest. So we got that. Now, which one's the next smallest? 3.16 or 3.63? Well, 3.16 is smaller. So that means square root of 10 is the next smallest number, square root of 10. So that means the last one would be the 3.63, which is 40 elevenths. So one thing to keep in mind is it doesn't want you to order decimals, right? It doesn't want you to list out 3, 3.16, and 3.63. It doesn't want these numbers as the answer. It wants the original numbers. It wants the ones that gave you the problem. It wants those listed in order. The decimals are just here to help us identify that, this one is the smallest number, this one's the second smallest, and this one's the third smallest. Decimals just help us figure out the order of these. So there's your answer, though. We have it right there. So if I go and check the solution, right, you can see that they've done it. They put in decimals, and then they were able to put them in order. And they put it on a number line as well. So they have a number line, and they kind of guessed where it was. So remember, this number was equal to 3, so it puts it right on top of 3 on the number line. The square root of 10, they rounded up. They said 3.12. Remember, we said 3.16, but same thing. So they took that number and put it at about 3.2 as far as that number line goes. And then 3.63, they put it just a little after 3.5, right? They put that number right there. So they just put it on the number line, right, to keep it, I guess, in order. We got one more example on this. Oh, we got 2, I guess. So order each set of cards from least to greatest. So again, just take a calculator, right? Now the first one's already in decimal, so that's good. Let me screenshot it so we can write on it. First one's already got decimals. We already knew that, right? We have 0.25. Let's figure out what the square root of 1/9 is. So in our calculator, again, we'll hit the square root. And if you have a regular scientific calculator, use parentheses. So parentheses 1 divided by 9, close parentheses. And remember, that's all in the square root. So hit enter, and that is 0.333, right? Repeating. All right, and then the last one is 6 divided by 25. No square root on this one. It's just 6 divided by 25. So actually, let me write down that this one was the square root of 1/9 real quick. All right. So 6 divided by 25. So 6 divided by 25. And that's 0.24. So 6 divided by 25 is 0.24. So now, of these, which is the smallest? The smallest one is 0.24. So that means 6 over 25 is the smallest number. So 6 over 25 wins. Now the next smallest is going to be the 0.25, right? Because that's smaller than 0.33. So 0.25, remember that was already a decimal, so we're going to obviously keep it that way. And so that means the largest number, the 0.33, which is the square root of 1/9. So remember, don't write the decimals in order because we already know the order of those. We want to write the original set of numbers in order. So we just use the decimals to note that this one was the smallest number. This one was the second smallest, and then the square root of 1/9 was the biggest. So that's why we put them in that order. So if you guys want to take a second, try this one out as well. I'm not going to do it on my calculator because I showed you how already, right? You already know how to do it. If you don't, just rewatch that last one. But I will show you the answer nonetheless. So I'm just going to type in something here so that it allows me to check the answer. And there's your answer for the order from the smallest number to the biggest. So that would mean that this number, the square root of 121 over 25, that had the smallest decimal. The square root of 5 must have been the second smallest decimal. And then 2.25 must have been the biggest decimal. So hopefully you tried that on your own. Try that on your calculator because it's nice if you guys do it yourself and then find out that you did it correctly. That tells me, that tells you that you're in a great spot, right? You're starting to get it. If you're not getting it, of course, remember, just ask me. All right. Operations with real numbers. All right, so I'm going to start this in the next video. So just to keep this one from getting too long and from, because this will be like hour plus, right? So I want to keep getting too long. I'm going to do this. I'm going to pause it here and I'm going to start this up in a new video. Okay? So I'll check you guys out in that one. Bye.